I'm Terry Holbert from Augusta High School, and we're going to do an elementary calculus lesson today. And today's is on graphing and graphing utilities. On this first slide that we have here, it's asking you to look at the connection between graphs and solving equations. Oops. So the graph and equation in two variable is a set of points with coordinates satisfying the equation. So what I have set up here is just a simple linear equation, y equals 3x minus 2, and a table of values. So I'm going to substitute these x values in. So I'm going to have 3 times negative 2 minus 2. So we have negative 6 minus 2, so negative 8. So my first point is going to be down here at negative 2, negative 8. Then I'm going to substitute in the negative 1. So 3 times negative 1 minus 2, that's negative 3 minus 2 is negative 5. So negative 1, negative 5 is approximately there. Substituting in 0, 3 times 0 is 0, minus 2. So we get 0, negative 2 for our next coordinate or ordered pair from our graph, which happens to be the y-intercept of our graph. If we substitute in 1, 3 times 1 is 3, minus 2 is 1, so 1, 1 is our next value. Substituting in the 2, 3 times 2 is 6, minus 2 gives me 4, so 2, 1, 2, 3, 4 would be about there. And the last one, 3 times 3 is 9, minus 2 is 7, so 3, 7. And these should all line up because it is a nice little linear equation. So we should be able to connect those dots. So we have an x-intercept somewhere between 0 and 1, and a y-intercept of negative 2. But down here it asks you, does the point 1 2/3, 2 2/3 lie on this graph? And if I look, 1 2/3, it looks like it's a possible value. If you look up here on the graph, it would be about in here. So it is a possible value, so we're going to substitute it into the equation and see if it actually works. So this is your x value and your y value. So we want to know, does 2 2/3, does it equal 3 times 1 2/3 minus 2? So I'm not sure, I'm just going to bring the 2 2/3 down. Still trying to see if that's equal or not. So if I multiply this together, this is 1 2/3 is 5/3, times 3 is 5, minus 2 gives me 3. And 3 does not equal 2 2/3, so it looked like it could possibly be on our graph, but it actually is not. Approximately 3.14159. So the pi is a constant number. The r in the equation represents the variable. A variable, we can substitute any number we want to in for it from a given set of numbers called the domain. And it's just some customary things here. Letters at the beginning of the alphabet represent constants, and letters near the end of the alphabet represent variables. So for example, in the equation, in the expression ax plus b, the a and the b will represent constant values, and the x is the variable. And one other thing about domain of a variable is a given set of numbers that can be substituted in for the variable. So here is my SmartView calculator, and this is my y equals menu up here, and we're going to type in 3x minus 2 in the y equals menu, and we're going to hit the graph. And so this is the graph that we saw, that we graphed by hand. And if we look at this, we still can see our y-intercept is about negative 2. But what I wanted to show you on here is if you hit the trace, we were checking to see if the point 1 2/3 or 5/3 would be on our graph. So if I hit enter, our 1 2/3, like we showed in the previous example, does equal 3. So we can look at a graphing utility and also confirm the fact that 1 2/3, 2 2/3 was actually not on our graph. So we're going to try another equation here. This one asks you to solve for f in terms of c. So we're going to take the equation, solve it for f. We're going to set up the table, and then we're going to graph it. So we have 5f minus 9c is equal to 160. We're going to solve it for f, so we're going to add the 9c over. So 5f equals 160 plus 9c. Divided by 5. And f is equal to 32 plus 9/5 c. So I'm going to take some convenient values for c. So since that's 9/5, maybe I'll take negative 20, I'll go up by 5s. So first, if I put negative 20 in the equation, we have 9/5 times negative 20, and we're going to add 32 to that, and we get negative 4. We're going to take the negative 15 times 9/5, so that is negative 15 plus 32, which is going to give me a value of 5. If I put negative 10 in, we have a good 14. If we put in negative 5, it is 23. 0 is 32, which is going to be your y-intercept. 5 is 41, 10 is 50, 15 is 59, and 20 is 68. So if we go over and graph, here I have the x-axis by 5s. So negative 20, negative 4 would be about there. Negative 15, positive 5, negative 10, 14, negative 5, 23, 0 is 32, and it looks like we have a nice linear equation going again. 10 is at 50, 15, 59, and 20, 68. So here is our, let's see if I can draw a straight line through there. Our graph of 5f minus 9c equals 60 in what they call a CF coordinate plane. So now, to look at that on a graphing utility, I have that same equation graphed here, but with 3 different window sizes. So I do have graphed here, f equals 32 plus 9/5 c. But in this window, we don't even see the graph. So by graphing conventions, we have x-min, x-max, and x-scale. So this here tells me that in my x-axis, it went from negative 10 to 10 by intervals of 1. This went negative 10 to 10 by intervals of 1, but we don't even see the graph. So if we go to this graphing window, negative 20 to 30, and notice these intervals are going by 10s, and negative 20 up to 10. Those intervals are also going by 10s. We barely see the graph in the window. So going out a little bit further, we get a nice picture of the graph. So negative 30 to 30, and negative 20 to 80, with both sides going by intervals of 10, gives you a nice view of the graph. Here, I'd like you to specify what the viewing rectangles on the graphing utility are. Here I have a cubic equation graph, y equals 2x cubed minus x squared. And this is the exact same graph in both of these pictures. Exact same equation is being graphed, but you have different viewing windows that show you different aspects of the graph. So can you fill in these two viewing window intervals? Okay, so let's just double check. The x-axis here went from -4 to +4, and it looks like it's going up by 2s. And in the y direction, it is from -40 to 60, and here the intervals are going by 20s. So that is how you would express the size of the viewing window. On the next one, it went from -0.2 to 0.6, and it's going up by 2/10, and -0.06 up to 0.02, and this one is going by 200ths. So that is how you'd express a viewing window. Here, I have a graph again, and it is asking you to compute the x and the y intercepts.